All right. The next question in the past question says find the differential coefficient. Don't be confused with English. Differential coefficient, derivative, all of them means the same thing, dy dx. Find the differential coefficient of y equals to x raised to the power of x. Okay, so this is a variable all over variable. Variable raised to the power of a variable. So how do we differentiate this? There are natural ways to differentiate this. First of all, remember, we have always differentiated functions like x equals to y equals to x raised to power maybe 3x x raised to the power of 3, or y is equals to 2x plus 5 raised to the power of 2. So you see, it is variable all over a constant, variable over number, variable over number. Now, the normal way is 3 times 1 is 3, then subtract 1 from the power. But what you are having in the case of this now is variable over variable, which is a different case entirely. So how do we differentiate functions of variable raised to the power of a variable? The first thing you do is to take the ln of both sides. Ln simply means natural log, that is log base e, which is what we call ln. Okay. I don't know. I don't know. For the sake of clarity, I think I will just take a little bit of a little step to arrive at the answer, so I can now explain the shortcut for you to really understand. Because what happens if maybe you go to the exam and you come x is equals to y is equals to x raised to power 2x, or y is equals to x raised to power 5x, or y is equals to x raised to power sine x, and then it changes, what will happen? So that's why I want to just explain a little bit for better understanding. All right, we go. So what do we do? Step 1, take the ln of both sides. So we have that ln y is equals to ln x raised to the power of x. Okay? You know that if you have log x raised to power n base a from the laws of logarithm, this is the log raised to a power. The power will come to the front of the log, and you have n, then this n will move to the front, then you'll be left with log x base a. That's what we are going to apply here, where this x will come to the front of this, because ln means log. Okay, but it's always a natural log of log base e. So that means that ln y is equals to x ln x. From here, we can now go ahead to differentiate. Know that if y is equals to x cubed, you will know that dy dx is equals to 3 times 1 is 3, then x raised to power 3 minus 1 is 2. We already know how to differentiate. But if I differentiate x, y is equals to x, the y over the x is simply 1. That's the derivative of a variable is 1. That one is clear. Now, you need to know that if you differentiate, anytime you differentiate y, the answer is always, just like if you differentiate x, you get 1. So also, if you differentiate y, you will get 1. But this time around, since you are differentiating y, you must include dy over dx. That's what you do anytime you differentiate y. Okay, so dy dx times 1 is simply dy dx, meaning that you should note that anytime you differentiate y, the answer is simply dy dx. Very, very important. Now let's go. If y is equals to ln x, please note dy dx is equals to 1 over x. That means that the derivative of ln x is 1 over x. So also, if I differentiate ln y, then the answer will also be 1 over y. The derivative of ln x is 1 over x. Also, the derivative of ln y is 1 over y. But since it is y, you will include dy dx. This is very, very important. So let's go. Let's differentiate the left-hand side. The derivative of ln y is 1 over y dy dx equals to, This is x times ln x. That's product. So you are going to use product rule to differentiate this. And what's the shortcut to differentiating product function? First of all, keep the first x times differentiate the second. What's the derivative of ln x? 1 over x plus keep the second, which is ln x, times differentiate the first. What's the derivative of x? 1. Okay, so this is 1 over y dy dx equals to x and x will cancel out and everything here will be 1 plus ln x times 1 is ln x. Next, and now this is my dy dx I'm looking for. So look at it here. Dy dx equals to 1 over y. When it moves to this side, it will become y. This is what I mean. Dy dx is equals to 1 plus ln x all over 1 over y. Moving down here, you have 1 over y. So dy dx is equals to, from your knowledge of simple manipulation of fraction, this will be 1 plus ln x times, this division will not change to times. Then y will go up and 1 will come down. So you have y over 1, which is simply y. That's what I mean. That when 1 over y moves to this side, it becomes y. So at this point, dy dx is y times 1 plus ln x is y into 1 plus ln x. So that dy dx is equals to, what is my value of y? Y was equals to x raised to power x. So I bring it. In the place of y, I'll replace it with x raised to the power of x into 1 plus ln x. This becomes the solution to this particular problem. It's very small, but mighty. All right. So what do I mean in essence? You want to see the shortcut. It's very simple. If you are told that y is equals to x raised to the power of x, then the y over the x is equals to, it's very simple. What's the derivative of the power here? The derivative is 1. So look at it, 1. Step 2, repeat the function now, x raised to the power of x. So 1 times x raised to the power of x is simply x raised to the power of x. Then into 1 plus ln x. This 1 plus ln x is just, not naturally. It's something you have to bring in all the time. Okay, of course, you can see that this is the answer. And if you check the options, that is exactly option A. X raised to the power x into 1 plus ln x. It's as simple as that. So, let me add something like Jara now. If say y is equals to x raised to the power 2x, then dy dx is equal to, it's very simple, the shortcut, differentiate the power. The derivative of 2x is 2. Step 2, repeat the entire function x raised to the power 2x. Step 3, include 1 plus ln x. And that is exactly how you get this done. Question number 7. It says evaluate. Please, I'm not going, according to that past question, I'm not going in a particular order. So, but here is a question in that past question. It says find or evaluate dy dx if x is equals to t plus cos t and y is equals to t plus sin t. Definitely, this is what we call a parametric function. Parametric, when x is with respect to another variable and y is a function of another variable, the same variable t and t, whereby this third variable that is introduced, remember we always have x and y. Now we have a third variable introduced, which is t, and this t now, which is the third variable, is what we call the parameter. So how do we differentiate a parametric function? It's very simple. I have that x is equals to t plus cos t. So just differentiate x with respect to t. That means dx over dt will be equals to, what is the derivative of t? Just like the derivative of x is 1, so also the derivative of t will be 1, plus, what's the derivative of cos t? The derivative of cos t is minus sin t. So minus sin t. Of course, plus minus will always give you minus. So this place is 1 minus sin t. 1 minus sin t. We're done with that. Move to the next function there. Y is a function of t plus sin t. That means that dy over dt will be equals to the derivative of t is 1 plus the derivative of sin t is cos t. So the parametric formula dy over dx is equals to dy dt divided by dx dt. Let's find out if that is true. That is say dy dt times dt dx. dt dx. So if this happens, this and this is going to have dy dx, which is dy dx. So that means this formula is very correct. So at the end of the day, this is equals to, what is dy dt? dy dt is 1 plus cos t. Put it there, 1 plus cos t all over. Dx dt is 1 minus sin t all over. You put it there, 1 minus sin t. You're done. 1 plus cos t all over 1 minus sin t. 1 plus cos t all over 1 minus sin t. That's option A. And you get that done. All right. The next question in that past question says, evaluate y prime. Y prime is simply dy dx. If x is equals to 8t raised to the power minus 1 and y is equals to 8t raised to the power of 3. So the solution, the first one, x is equals to 8t raised to the power minus 1 and y is equals to 8t raised to the power of 3. This is still parametric function where x is a function of t and y is a function of t, where the third variable there, t, is a parameter. So you differentiate it parametrically as dx over dt. Please note that this a here is just like saying 3t raised to the power minus 1, where a represents a number. So it's actually a variable. A constant. That's a number. All right. So let's differentiate this. This is going to be minus 1 times a minus a. Then t raised to power. Remember, the power times the coefficient. Minus 1 times a is minus a. Then subtract 1 from the power. Minus 1 is minus 2. So, minus 1 times a is minus a. Then t raised to power minus 1 is minus 2. We're done with that. Dy over dt will be equals to 3 times a is 3a. Then t raised to power 3 minus 1 is 2. We are done with that. Then automatically dy dx is, the formula now is dy over dt divided by dx over dt, which is equals to, what is dy dt? 3at square. 3at square all over, what is dx dt? Dx dt is minus a t raised to the power minus 2. So this is equals to, a and a will go. So I have minus 3. T is here, t is here. You pick one t from the laws of indices. This is 2. Look at it here. Then this minus 2 here will move up and become plus 2. So the answer is minus 3 t raised to the power 2 plus 2 is 4. That gives you the final answer. And that is option D. Find the inverse of the function f of x equals to 3 into 5x minus 1. So the question is simple. How do we find the inverse of a function? It's very simple. What do? Set the function to be y. That's the step 1. F of x is equals to this. Set the function to be y, which is equals to 3 into 5x minus 1. Step 2, make x the subject of formula. And of course, you know, you have to open this bracket first. So that means that y is equals to 3 times 5x is 15x. 3 times minus 1 is minus 3. Then making x the subject of formula, you collect like terms. So this is y minus 3 will move and become plus 3 equals to 15x. I'm looking for the value of x. What's standing with x? 15. Divide both sides by 15. So if I divide this by 15, divide this by 15, this and this is gone. X will be equals to y plus 3 all over 15. Next step, we all know that in fraction, if I have 8 plus 4 over 2, for instance, or 8 plus 3 over 2, for instance, I can split this as 8 over 2 plus 3 over 2. Yeah, if you want to get back to this from your elementary arithmetic, primary 4, that if the denominators are the same, you add the numerators and pick one of the denominators. So that will be 8 plus 3. Look at it, 8 plus 3. All over, pick one of the denominators. You get back to this. So that's the same thing we are going to do here. So we say that, okay, first of all, step 1, we write this to be y equals to this. Step 2, make x the subject of formula. Look at it, we have made x the subject of formula. Step 3, interchange the position of x and y. So here will be y equals to, here will be x plus 3 all over 15. We have interchange the position of x and y. So after interchanging the position of x and y, then automatically the inverse of the function, which is written as f inverse of x, will be equals to x plus 3 all over 15. That's the answer. But from the options, you will notice that they further simplify the fraction to be f inverse of x equals to x over 15 plus 3 over 15. So f inverse of x is equals to x over 15 plus 3 here, 1, 3 here, 5. Then f inverse of x is equals to, if you notice, something is common because 15 here is 3 times 5. So this 15 is 3 times 5. That means that 1 over 5 is here, 1 over 5 is here. I bring out 1 over 5. Let me write it here. Please, let me write the answer here. Let me repeat this, please. So look at it. F inverse of x is equals to, now this is 15 over x over 15, which means x over 3 times 5 plus 1 over 5. So this is equals to, you know that 1 over 5 is here. Also 1 over 5 is here. You bring it out, 1 over 5. So what am I left with here? I'll be left with x over 3. Look at it, x over 3 plus, I have factored out 1 over 5. Look at it. So what I'm left there will be 1, because 1 over 5 times 1 is 1 over 5. And 1 over 5 times x over 3 is x over 15. So this gives us the final answer. And that is option D.